My name is SP Tobela. I'm a lecturer at Ehlanzeni TVET College, based at Mashishin campus, under the program Engineering Related Design. So today, I'll be offering Engineering Systems NQF Level 2. And we'll be focusing on the topic hydraulic systems and their components. So, what do we mean by a hydraulic engineering system? We say a hydraulic engineering system, it uses liquid or fluid to transfer power. Like for example, you have a hydraulic jack. And therefore, let us look at the component of hydraulic system. So which are the components that makes up the hydraulic system? See, the components that makes up the hydraulic system, we have a reservoir, a pump, actuator, control valve, and fluid lines. Now let us look at the function of the hydraulic engineering system component. Then the first one, we'll look at the reservoir. What is the function of a reservoir? We say that a reservoir stores energy that is not being used in a hydraulic system. It stores the energy that is not being used in a hydraulic system. And therefore, let us look at the pump. What is the function of a pump? The function of a pump, we say a hydraulic pump, first it converts mechanical energy into hydraulic energy and pushes on a hydraulic fluid and creates flow, which means that a pump has two functions, of which is to convert the mechanical energy into a hydraulic energy and also to push on the hydraulic fluid and create flow. And then now let us look at the actuator. Then an actuator, we say that a function of an actuator is that in a hydraulic system, an actuator receives pressure and converts it to mechanical force and emotion. It receives the pressure energy and converts it to mechanical force and motion. Therefore, if you can check an actuator and check the pump, you can see that the actuator do what is vice versa to the pump. While the pump converts the mechanical energy into hydraulic energy, the actuator takes back the hydraulic energy back into a mechanical force and motion. And then now let us look at the control valves. The control valves, we say that the function of a control valve is to control the operation of the actuator and regulate pressure flow. So in hydraulic engineering system, we also have the advantages and disadvantages. Then let us first focus on the advantages. We say that the advantages, first, hydraulic fluid is incompressible, meaning that a hydraulic fluid or a fluid cannot flow unless a force is being applied. And then we also say hydraulic systems are self-lubricated. Remember, this is an advantage because if you are working with with engineering systems, the parts need to be lubricated. But then in this case, since it's a hydraulic and the hydraulic uses fluid, so it's self-lubricated. And then thirdly, we say the pressure that is applied anywhere in the fluid is transmitted equally throughout. Therefore, since we have looked at the advantages, now we want to check the disadvantages of the hydraulic system. First, to say, if a hydraulic system equipment is overloaded, it can fail. Remember, hydraulic system must not be overloaded. First, it can create noise, or the system can start to be noisy, so that every time avoid that to keep the system or the hydraulic system overloaded. And then secondly, we say fluid under extreme pressure can be dangerous. So if you're working with fluid, please make sure that the fluid is at a certain level. It must not exceed a certain pressure to avoid the danger. Then, therefore, now let us discuss what do we mean by Pascal's Law. We say that the Pascal's Law is when pressure exerted at any point in a confined compressible fluid is transmitted equally in all directions throughout the liquid so that the pressure ratio remains the same. Pressure exerted at any point in a confined incompressible fluid is transmitted equally in all directions, meaning that the pressure that is exerted in an enclosed area. So you can also, Pascal's law can be mathematically expressed by P is equals to F all over A. So if you say P is equals to F over A, all over A, where our P is our pressure and is measured in Pascal. And we have our force by the symbol F, measured in Newtons. And then also have our A, of which is our area, measured in meter squared. Then now, let us look at the diagram. If you can see from the diagram, we have a force that is being applied in a container or in a piston as being labeled. That force that is being applied in a piston causes pressure to transmit the fluid equally in all directions. As you can see, we have it indicated in arrows. Now let us apply the Pascal's law in terms of calculation. If you look at example 1, example 1 says calculate the pressure exerted on a piston which has a diameter of 80 millimeter and supplies force of 1,200 newtons. The pressure applied. Therefore, it's example 1. Example 1, let us check on the given data. We are given D, which is the diameter, is 80 millimeters. We are also given F, of which is the force, as 1,200 newtons. And then they say you must calculate pressure. Pressure is your unknown. Pressure is your unknown. But then since you know from Pascal's law, we say that P is equals to F, of which is our force, all over A, of which is our area. But then now we can look. You have a force, of which is 1,000 newtons, but then you are not given your A. You are given a force, but then you are not given your A, of which is your area. But then you are also given the diameter. So you know that, okay, since we are working with a piston, and you know that the formula to calculate the area of a cylinder, it's pi d squared all over 4. So first we must calculate the area. And then since we are given D, we are given D as 80 millimeter. And remember, we said area is always measured in meters squared, or in this case, we measure area in meters squared. So we'll say, since our D, we're given as 80 millimeter, we say D given as 80 millimeter. Then now, first you must convert your millimeters to meters. And you know that 1 meter, we know that 1 meter is equals to 1,000 millimeters. So if you want to convert the diameter, means that you will say D is equals to 80 divided by 1,000. Your 80 divided by 1,000. So if you say 80 divided by 1,000 from our calculators, you can also calculate. You will get 0.08 meters. 0.08 meters. Remember, we're only calculating the diameter. In fact, we're only converting the diameter from millimeters to meters. Now, we want to calculate the area. We want to calculate the area. Therefore, your area is said to be pi d squared all over 4. Therefore, your pi, it's pi, or you can simply say 3.142. Then you say times your diameter. We have converted the diameter into meters, remember? So now we have 0.08 squared divided by 4. 8 squared divided by 4. So we'll say pi times 0.08 squared all over 4. And then I will get 5.02, and then round off to 3 decimals, 0.27 times 10 power minus 3, of which it's millimeter squared. But then remember, the question was saying calculate the pressure. Now you only got the area, you still have to calculate the pressure. So for the formula to calculate the pressure, it's PF all over A, and your force is 1,200, then divide by our 5,027 times 10 power minus 3. So if we say 1,200 from our calculators, 1,200 divided by 5.027 times 10 power minus 3, then you'll get 238.71 times 10 power 3. Remember the SI unit, it's Pascal, of which you can still write this. Remember, 10 power 3 is the same, it's kilo. So you can simply say, therefore, okay, you can simply say, then you can simply say, therefore, is equals to 238.71 kilo Pascal. Right. So then now we are able to calculate our pressure. Then let us look our next example, of which is example 2. Let us look at our next example. If you are doing calculations, especially with hydraulic system, it's very important to check the units, the measurement, and to check the given data and to understand what is it that you are required to calculate. And therefore, let us look at our example 2. Example 2 says an input piston A is smaller than output piston B, and then piston A has an area of 0.02 meters squared, and piston B has an area of 0.02 meters squared. And a force of 1,000 newtons is applied to piston A. Then the question says, what will be the output force exerted by piston B? Then, if you can check from the diagram, we have our piston A and our piston B. And if you can look, there is a pipe that connects piston A and piston B, of which means that the pressure that is being applied on piston A, it will be the same as the pressure that will be exerted in piston B. So then, let us look at our given data. from example 2. Therefore, our given data, we first check with piston A. With piston A, they say that piston A is smaller than the output, and piston A has an error of 0.002. Piston A has an error of 0.002 meters squared, and they say piston B has an error of piston B have an error of 0.02 meter squared. And then say a force of 100 newtons is applied to piston A. So piston A, we are given a force of which is 100 newtons. Therefore, then we are expected to calculate the output force exerted by piston B. The output force, the force of piston B, you can say it's FB, of which is piston B, force of piston B, and then you're supposed to calculate. And therefore, so since if you can look from our given data, of which is piston A and piston B, and then we know that the pressure applied at piston A is the same pressure that must be applied at piston B, since they are connected together, or they are joined together by a pipe. So our pressure applied at piston B will be the same as pressure applied at piston B. So now, remember, we're supposed to calculate the force that is being exerted at piston B. So since we have area of piston A and the force of piston A, we can be able to calculate the pressure being applied at piston B, at piston A. So piston A, of which is the pressure, you'll say is equals to pressure A, which is with the area all over the force applied. And therefore, our area were given as 0.002 all over our force from our data. It's 1,000 newtons. Therefore, let's do our calculation. We say 0.002 divided by 1,000. Since we are given piston A, we say piston A is the same as piston B. Therefore, piston A is given as force A all over our area. And therefore, we say our force applied, it's 100. So we say 100 all over our area. We say 0.002. So to do our calculation, we say 100 divided by 0.002. Therefore, we get 50,000. If you say 100 divided by 0.02, you will get 50,000 Pascal. And 50,000 Pascal can be written as 50 kilopascal. But then these answers are the same. 50 kilopascal the same as 50,000 Pascal. Then since we have already calculated PA, of which it's our 50 kilopascal, and we know that our pressure applied at piston A is the same as pressure applied at piston B. So now we can be able to calculate the force that is being exerted at piston B, of which we'll say, since the PA, pressure applied at piston A, is the same as pressure applied at piston B, So which means that our pressure applied at piston B is still the same as 50,000 pascals. And then remember, we're supposed to calculate the force. So we'll simply say BP is the same as FB all over area. And then our force is what we're looking for. So we'll do cross multiply, and our FB will be BP, of which is the pressure applied times area. And then the pressure applied, we say it will be 50,000 times the area. The area, it will be 0.02. Since we're calculating the force and we're given our pressure at piston B, we say pressure at piston B times the area at piston B, of which we'll say 50,000 times 0.02. And 50,000 times 0.02, it will be 1,000 newtons. 1,000 newtons. So this is how you're supposed to do our calculation. Please practice calculation. They are very much important in hydraulic engineering system. So this will be the end of our lesson. I hope you enjoyed. And if you have any question or any comment, you can follow us on our website, of which is ehlanzenicollege.co.za, or on our Facebook, our social media platforms, of which we are available on Facebook, Ehlanzeni TVET College. We are also available on Twitter at Ehlanzeni TVET, and we are also available at YouTube. It's Ehlanzeni TVET College. Thank you.